So she's going to talk today about blurring the boundaries when managing AI. Please have a warm welcome for Lauren Waardenburg.
Good morning, everyone. Now I feel a bit bad that I don't have such a nice warm up and that we all need to do some morning exercises. So I hope you won't fall asleep after all this activity. Um, I'm very happy to be here. This is the first time ever I speak to a whole crowd of agile experts, which I hope means that I'm actually preaching to the crowd today. Because normally, when I speak to what we in academia call practitioners, um, it is. I have to tell them that you need to blur boundaries and that you need to work together between different people, etc. I hope that in this crowd, that is actually something that you are very happy of, that I am preaching that and that you will follow with me. But with that, I also have a few questions towards you today that I hope you can take back and ask within your organizations in the transition towards managing with and for AI, a topic that we are all now talking about basically every day, right? With the emergence of generative AI out of the blue into every organization. What I will be talking about today is not only generative AI. I will introduce a bit more the background that I have in a bit, but I will talk about basically all types of AI systems when I talk about the blurring boundary concepts, from the very early, what we now call traditional machine learning systems, to generative AI. And I hope that you will see that actually the issues and the questions that are interesting within organizations remain rather the same. So it doesn't really matter if we talk about the very advanced generative AI systems that we have now, or the more simplistic predictive systems that we thought were the next level a few years ago. Now, who am I? As Sasha already said, I'm a professor at ESSEC Business School, professor of information systems, they call it, meaning that I study technology and its influences on work and organizing. I'm also an ethnographer. That's basically the method that I use. And that means that I embed myself in organizations most of the time for multiple years to understand what is really going on within an organization. So instead of just going there and doing surveys or interviews, I really work with this organization for quite a long time to understand how work and organizing is really changing. My biggest project is with the Dutch police. That started in 2016, and I still do that. So it's been 9 years now of me studying how the police organization has changed, is changing because of the development and introduction of AI. Within the Dutch police, that was kind of a predpol system. Maybe you've heard of that. The prediction of crime a week in advance where crime is going to happen. And that fundamentally changed the police organization, both inside as well as on the street. And I will have some reflections on that during this keynote. But more broadly, I've studied a lot of different organizations. And based on that, with two other co authors, I wrote a book, like Sasha already said, Managing AI Wisely. And that is a management oriented book based on 8 different large international organizations, amongst which Air France KLM, for example, but also Volkswagen. I did a few interviews at Volkswagen actually in Munich a few years ago. So it's funny to be back here too with this book now. In which we studied these organizations who were at that point front runners. They were the ones who already developed and implemented in AI in their organizations. And we extracted the best practices. What did they do? Where did they hit boundaries? What were the core things that they were doing that others should do too if they want to implement AI? And one of the main things that came from that was the concept of blurring boundaries. So the agile concept that for you hopefully is very intuitive came through in all the studies that we did around AI implementation. Because with AI and with these technologies that bridge between all these different disciplines, it's basically impossible to keep the standard silos within organizations alive. So today I will talk about some of these examples, not all of them, but if you want to know more, you can always ask. Also, this book is published by Edward Elgar, and because of that, extremely expensive. If you're interested in the book, just send me an email and I can send you the PDF. Ah. Now, don't tell Edward Elgar this, by the way. I hope there's no one there in the crowd. Now, about this book, of course, let's first start with what is artificial intelligence actually, and I will go deeper into this in a little bit. But let's start with the definition. If we look at artificial intelligence, the definition has changed many times. We started in the 1950s, but what we talk about now when we talk about artificial intelligence, it's machines performing cognitive functions usually associated with human minds, learning, interacting, problem solving. This is a definition that has been around for a little while, and it's still applicable even now with generative AI, which is nice, meaning that it's actually kind of solidifying. But when we talk about artificial intelligence nowadays, it's mainly machine learning. So it used to be expert systems, etc., which are not machine learning at all. But nowadays, when we talk about AI, it's machine learning. What do these systems do? Well, they can generate insights that we as humans think we cannot achieve, right? They can combine large amounts of data into insights that give us something new. That's the idea. But what you see in practice is that it's often very far removed still from the actual workplace. And that leads to issues around how to develop and implement AI systems for organizations so that they actually work, so that people can work with them. And for today, I would like to structure this talk around 3 different questions. Number 1 is, what are the technical details of AI actually? Because I think to be able to organize with and for AI, you need to understand what these different types of machine learning are. So I'll go through quickly through these different types of machine learning, give you a crash course into the different types of machine learning so that you will also see what I mean when I say who are involved. Because depending on the type of machine learning, the activities that you need to do afterwards are also different within or externally to an organization. And the final question today is, how does work actually influence AI then again? So what is the relationship between AI influencing work, but also work then influencing AI again? What does it mean, for example, for the AI systems and what they can produce? Now, let's start with what are the technical details. And I hope you will not fall asleep in this part of the session. So I'll try to make it as interesting for you as possible. So broadly, AI systems depend on or are characterized by 3 different things. Number 1 is that they depend on large amounts of data. And the more extensive and elaborate the AI systems become, the more data you need. Within organizations, we still see that that is a big issue because often organizations think that the data is ready, but actually it's not. We'll talk about that in a little bit. That's number 1. Large amounts of data are necessary. Number 2 is that because of the machine learning, these systems are self-learning. So they can adjust over time, adjust their settings, their feature weights, so that they can achieve the optimal and most accurate outcomes. But because of that, they are also increasingly black boxed. Basically, no one, I think, in this room knows exactly how ChatGPT comes to its outputs. Right? So the black box idea of, well, how did you even get to that, is becoming bigger and bigger. But because of combining these two, these large amounts of data and the fact that it can learn by itself, it can also generate these insights that are considered new. So these systems can make sense of patterns in data that we, with our human minds, cannot comprehend by ourselves. That's also the advantage of these AI systems. That's also why we're also interested in using them now, because they can do something that we would like to do by ourselves, but that is rather difficult. Now, if you look at this is still a high level. So let's look a little bit more in detail to what machine learning is. So machine learning actually has, again, 3. So this is a very academic thing. Academics always think in 3s. So I will go through the whole presentation in 3s. So here we have 3 things again. supervised, unsupervised, and reinforcement learning. I will go through the three very quickly, just because it's important to understand the difference and the requirements of these three different types of machine learning. Also know that supervised learning, does this work? No, yeah. Supervised learning is still the one that is used most in organizations. The more to the right we go, the more we talk about the large tech companies who have the amounts of data that is available and necessary for this type of learning. So supervised learning, we most of the time explain that by saying it's learning through labeled data. So you have a data set that you need to prepare for the AI system to learn. Meaning that if you want an AI system to learn to make the difference between a square and a circle, you need to feed a lot of data into this system that is prepared by contouring every circle and labeling every circle. So here every circle and every square, of course, also has a contour and a label. By feeding that into the AI algorithm, at some point it will be able to identify the square and also give the label square to this data point. If you look at, if you want to teach it how to recognize a fork, you need to feed it a lot of images of forks with a contour. I couldn't get the contour in my PowerPoint slide, so I just add, you need to contour it, you need to label it with fork, and at some point it will be able to identify a fork with the label fork. Supervised learning is therefore still dependent on a data set with both the inputs and outputs. So you teach the system to just do something more efficiently, more quickly than we can do as humans. But basically everything in the data set is known. You know, when you teach an AI system to recognize crime, the data set will include all the identifiers of crime and whether there was a crime or not. Everything is known. So these systems don't produce anything new. They just do it more efficiently. It's supervised because they say it's still a human teacher. We as humans put the data in there. We teach the system what it will see by contouring and by labeling. So the whole idea of supervised learning is input, then you have the model, and then you have the output, and everything is determined still by the humans that make that data. This is the type of learning, as I said, that is mainly used in organizations still, whenever it is about optimizing processes, etc. You don't need unsupervised learning for those kind of things. So supervised learning is a type of machine learning that is very prevalent in organizations nowadays and leads to a lot of questions around data that we will talk about in a little bit. Then unsupervised learning is learning through finding patterns. So in that case, you're actually not teaching it what you see. If you see the difference between these two data sets, on the left you have the data set for the supervised learning. There you constantly add the label of what it will see in the data. On the right you don't. On the right you just add the images or the data patterns to the system. You don't give it a label. You trust that the system can find whatever group it belongs to by itself. The difference between supervised and unsupervised is then that it doesn't know what it sees, and it also cannot tell you what it sees. So in the supervised learning, it can always give you the label cat. But in unsupervised learning, you didn't give it the label in the first place. So it cannot give you the label cat. You have to add another layer on top of that. So there it already becomes more complex. But the good thing about this is that it can come up with groups and patterns that we didn't see ourselves in the data. So you hope through unsupervised learning that the algorithm can actually identify clusters that you may not have seen before. It's good for example, if you have a large data set on customer data, on customer behavior, to then identify new types of customer clusters, for example, that you didn't yet see in your organization. What you do in this case is you feed it more data than the one for supervised learning, and through that the system will start to identify common patterns in the data. So for the forks, it's not anymore a label, but it's actually a lot of the same images, so that the system will at some point identify all the same elements and say, well, this is the same group of tools, a fork, but the fork it cannot tell you. So in the case of unsupervised learning, you do not have that external teacher anymore. You're not telling it what it sees. You're giving it different kind of categories to see, you could say. So the whole idea of unsupervised learning is that it needs to detect different type of properties in data. And most of the time we give the example through images, but it can be anything. Like I said, can also be customer properties, for example. And the thing you're trying to do constantly is to find patterns or clusters in that data so that you can then work with that output. Now, the problem with unsupervised learning is this. I don't know if you've seen this example before, but in unsupervised learning, you really trust the system to see what we see. So the idea is that it picks up on identifiers that we intuitively as humans pick up on. This is an example actually of Google, who tried to train an unsupervised system based on all the images of animals that they had in their database. And they found out that basically all the animals were rather easy to predict. But the moment that they tried to predict a wolf versus a dog, they saw that every time that there was a puppy playing in the snow, the system said that it was a wolf. They didn't understand why, because we as humans see the difference between that wolf on the left and the puppy in the middle, right? We find the puppy really cute and fluffy and the wolf a bit scary. And we also see that there's a difference in the nose and the fur, etc. So why did this system actually identify that puppy constantly as a wolf? Does anyone have a hunch why? Because of the snow. Yes. So this system did not at all learn to identify wolves because of the features of the wolf. This system learned to identify wolves based on the background. That's the danger of unsupervised learning, that it finds patterns in data that are maybe completely irrelevant. So it comes up with outputs where it thinks it's making sense, but to us it doesn't. So unsupervised learning, even though it has the potential of coming up with something new, it also has the potential of coming up with something completely irrelevant. Now we talk about that with the term hallucinations. We talked about that before. Before that we said errors. So that's one of the dangers of unsupervised learning. And one of the problems of unsupervised learning is that it's still rather stuck to identifying one thing. So it can identify clusters of things, but it will never be able to combine different things. So in this case, we see both a puppet and a fork and maybe even a spoon. An unsupervised learning system will never be able to do that. So it's either able to identify all the forks, or it's able to identify that this is a puppet, not both of them. To do that, there's another type of learning, and that's reinforcement learning. And in that case, so reinforcement learning is, they also call it learning through reward or punishment. And it's learning from your environment. They say, well, that's a rather vague term, but the most famous example of that is AlphaGo. Maybe you've heard of that system before, the AI system that could win from the Go master. And what you do with reinforcement learning is you do not just say we have a lot of data, now immediately produce an output and we identify whether it's good or bad. But instead you make it go through a lot of different steps in which you as a human do not have any influence. So you make it play a game, for example, in which you only tell it you need to win. And whatever steps you make in between, we will not say anything about that. We will just say at the end whether the outcome is good or bad. If you win, the outcome is good, positive reinforcement. If you lose, the outcome is bad, negative reinforcement. And this way, these systems learn to combine different steps in ways that we as humans wouldn't have done that. So there are a lot of videos online on YouTube on the games between the Go Grandmaster or the Go Master and AlphaGo, in which at some point there are also these videos where they give input and give feedback on the system. And at some point you hear a few Go masters say, now it made a mistake. Now it did a move that we would have never done. That's wrong. And those moves were eventually the moves that made this system win. That's the thing with this kind of reinforcement learning, that it can come up with combinations that we didn't know of. Now, so reinforcement learning is all about cumulative rewards. So the better the combination, the higher the outcome, so the higher the reward. And through that, it also learns through trial and error. And why do I talk about reinforcement learning here? Because reinforcement learning is actually the type of learning that brought us generative AI. Of course, generative AI is a combination of a lot of different models. So there's also a lot of unsupervised learning going on in generative AI. But one of the main ways in which it learns to adapt to our behavior and to produce something that we like is through reinforcement learning. And this is an example of me asking ChatGPT if it could create an image of what generative AI looks like. And this is what it produced. And here at the bottom, you have the thumbs up and thumbs down. That's reinforcement learning. So it combines a lot of different steps to generate this image from my prompt. I say thumbs up or thumbs down, and through that it learns whether this image is correct or not. So every time that you do this, when you use any of these systems, keep in mind you're contributing to reinforcement learning. You can also reinforce it by asking another question. So I asked it, what if it would be a human? And then it produced this image. I'm not sure if this would lead to a positive or a negative reinforcement on my side. But yeah, so this is the outcome of the reinforcement learning step. And this is, of course, less used by common organizations, you would say, because reinforcement learning, as you can imagine, requires extreme amount of data. Though that's most of the time the big tech that can produce these kind of algorithms, that doesn't mean that we cannot use it, though, as we all see in our everyday behavior, probably. So that was my crash course into what is AI. Now let's go into the second question, and that's who are involved. Because if we talk about these different types of machine learning, there are different actions that you need to take. But in general, these actions can be grouped into 4 different areas of blurring boundaries, or 4 different areas of managing AI wisely. And that is organizing for data, for testing and validating, for brokerage, and for change. I will go through these 4 rather quickly because I don't have all day. But if you want to talk about any of the elements more, I think we have some time at the end also for some Q&A. So let's go into the first, organizing for data. By the way, I will structure all these 4 according to a common myth around the topic. So number 1 is data is the new gold. Because when we talk about data in organizations, when I talk about data with organizations, often organizations tell me, yeah, we gather all the data that we can because that way we can use AI. Recently, I was talking with the Dutch military who said, yeah, we have all this video data, so we should be able to do something with that, right, with AI. But that's not necessarily the case, because in the case of data, you can have as much data as you want, but if it's not prepared well for an AI system to learn from it, you cannot capture any value from it, at least not in the case of AI. So that means that there's a lot of work going on behind the scenes related to data. One of these types of work is the work of the data engineer that we don't often talk about. We talk a lot about data scientists making the AI systems. We don't often talk about the data engineers doing all the cleaning work, for example, or structuring the databases in a way that is necessary. Also, as I talked about the supervised, unsupervised learning, if you want to develop a supervised learning algorithm, it means that you need to code all this data. You need to label all this data. Who's doing that? Where do you get that data from? When you develop an AI system internally with your own data, it means that somehow these labels have to be added. So how are you going to do that? Who's going to do that for you? And who's going to produce the data in the first place? So in the case of Air France KLM, they developed an AI system to predict how many meals should be on board an airplane. And they did that to actually optimize the work of the catering services. But the ones who had to produce the data for this system were actually the ground crew, the people who check in and board the people on these airplanes. That's where the data came from. These people did not see the AI system in their work at the end. So they were doing all the data work, but they weren't benefiting from it with a more optimized process afterwards. So how do you involve these people in your development process? Now, in the case of Air France KLM, that was a very agile organization in which actually the project, the project manager was a ground crew member herself. She was hired in and was able to bridge between all these different parties and explain why it was necessary that certain work was done. That kind of organizing for data work is way before the actual AI system is developed, continues through the development of the AI system, because sometimes throughout the development of it, you find that you need other types of data or that you need to do a different type of data work for it. And even after the AI system is finished, that data work continues, because the whole idea of AI is that it keeps on learning from the data. So organizing for data is something that is going through all the stages of AI development and implementation, and one of the core activities around AI. And one of the core activities that blurs the boundaries between most of the parts of the organization involved. That also leads to questions about, do you want to develop an AI system internally or externally? What does that actually mean for organizing for your data? Here I have just a few bullet points added. There are, of course, more advantages and disadvantages of internal and external development. But for example, if you develop it externally, it means that you have to, the disadvantage of that is that you have to give away a bit of the data. How do you deal with that? Who is then responsible for the data? An advantage of it is that most of the time there's a lot more data expertise outside of organizations than internal to the organization. So different kind of challenges. If you develop it internally, you have more control, but most of the time also a higher challenge IT related. So different questions, different people involved. So here I leave a few questions for you also to hopefully already answer or take with you back to the organization. So questions around organizing for data is, for example, what is at first necessary to gather or produce the right data? Who is involved there? Do you want to do that internally or externally? And how do you make sure that you collaborate between these different data specialists and the different experts within organizations who can say something for you about the data? Now, when you have that all under control, so you have the data set that you need for developing AI, it doesn't mean that it's already done, that you can implement it. Number two, the common myth number two is when the system is technically sound, it means that it's also successful. Well, you as agile experts probably know that that is not often the case, because there's a whole human force in organizations that is not always happy with a technically sound system, because a technically sound system can still create a lot of stress in work contexts. So that means that to actually test and validate it, just technically testing is not enough. Just saying it's very accurate doesn't mean that it's helpful for people in their work. Instead, there are a lot of different elements involved. Well, my pointer is not really strong. There are a lot of different elements involved, which are, of course, on the left, the technical aspects, but also more ethical questions. You have a very technically sound system, but is it really ethical to use it? I said before with the police, my main case, they predict a week in advance where and when crime is going to happen. And we've seen in the US that turned into a very individual targeting system in which they said, well, you need to follow this person to make sure that this crime is not happening and arrest this person before it happens. So it might have been a very technically accurate system, but do you want to really include that in your work? On top of that, there are also organizational aspects. So sometimes the stress of work is just too high to add another technological tool to that kind of work. How do you make sure that it fits within their work processes? So it's not only technical testing, it's also more socially validating the system. Does it fit within your work practices? Does it actually contribute something? And in that kind of context, the question is also, what is the role of a developer there then? Because typically, we consider developers or data scientists as the ones who need to create these AI systems, right? You have the expertise, the technical expertise of developing AI. But what do you do as a developer in validating those AI systems? What we saw at Air France KLM, for example, the meal predictive system was intended, as I said, for the catering services, but the catering services really on the pier, so the airplane area at Schiphol. And that's a very stressful type of work. These people need to cater all the different planes of Air France KLM across the whole area of Schiphol. So they don't have a lot of time to look at an AI system and see if the predictions make sense, for example. So using a tool like that requires a lot of additional effort into showing you this is actually making your work more efficient. So what they did there with the developers was actually sending the data scientists into the work of the caterers. So the developers joined the caterers for a week on the pier to see what that work actually includes, the kind of stress that is involved. And that way the developers could actually create a system that fit within the work practices of the caterers, that wasn't adding stress, but taking stress away. In addition, there are always laws and regulations. I won't go too much into that right now, but we all know that we now have the AI Act, which increases, again, the challenges of, well, you have an accurate system, but is this even allowed in practice? And how do you make sure that you involve the users in your work practices? And this is something very agile, right? So to bring in the users very early on in the development process, to test early versions to see if this actually works within the broader domain. Now, point number 3, a tested and validated AI system is directly usable. This is a point about a whole new role in organizations. And the funny thing is, so normally when I present this to organizations, they are very interested in the role that I'm going to present. You are probably saying, well, yeah, isn't that probably the product owner in your in the agile organizing? Because the whole point between AI AI developers and users is that often there's a large distance between this technically and socially tested and validated system. It's all nice. And then the actual users. Think, for example, of police officers. You have this AI system that creates a rather abstract map of where crime chances are higher or not. And then you have police officers who basically just want to catch thieves. They are not necessarily going to sit at their computer and make a whole analysis on where they need to be. They just want to go and catch thieves in the moment. That is not really a close connection between the AI system and the user. And you see that a lot, not only between AI systems and police officers, but in general, there's a rather large distance between the actual work and the abstract outputs of AI. Now, what you see happening now is that there is a broker in between. We call that an algorithmic broker, but there are different types of terms for it. Analytics translator was also another term that is used as one of the upcoming roles. Actually, Gartner recently presented all the different types of roles that are now upcoming because of AI. And the translator or broker was one of the most influential roles they presented. And the idea of a broker is actually a role that is in between the AI system and the user, to make sure that the AI system is translated into something that is useful in practice. So let's stick with the police officer example. You have this abstract output. What does the broker? They select the times and places that are most relevant to the police officers. They add some additional information to it, maybe an area where they know that the logs are inherently bad, and now there are a lot of house burglary predictions. So just look in that area because the house state is bad, for example. So they add contextual information to make it more useful in practice for the users. Now, these brokers have shown to be very influential on whether AI systems will actually be useful in practice. Any organization that we've studied in that book, of the 8 organizations, 6 had some type of broker in there. 2 didn't. One was because the AI or the users were rather technically savvy themselves, so they could make sense of the AI system. And the other organization that didn't actually failed implementing AI. So I don't know if that says something about the broker, but this role is extremely central now in implementing AI in practice. For me, it's slightly different than, for example, a product owner in an agile team, because the broker actually should be there for a longer term. So it's not a temporary function in which you just help the users briefly to, adapt and adopt the AI system into their organization. Ideally, this broker is there as a more permanent role, because these AI systems keep on developing. They keep on changing, and the broker is there to help the user to actually implement that AI and make sense of that AI over time, to deal with the black box nature also, for example. So in that case, the broker is mainly, in the permanent broker case, it's responsible for interpreting AI over the longer time. You can also have a broker that's more on the supportive side. Oh, I see that my support on the left fell out of the slide. But on the left, it should say support. On the supportive side, then they don't translate. Then they just basically copy-paste whatever is necessary and do more of the administrative task. But that most of the time doesn't really work. You can have a temporary broker in case you have a user community that is more technically savvy and just needs a bit of help in the beginning. That is more, I think, related to the agile organizing perspective. So those brokers are central and are, to my view, very important in organizing for AI. But there's also a danger. And that is that you put a human in between this AI system and the user. They always do their own thing with it. So they will also always start to make their own decisions on whether it's relevant or not, whether it's hallucinated or not, what you should focus on, what you shouldn't. So this role, not only is it important to organize or put it into the organization, it's also very important to manage them. So what I saw in the police, for example, I will not go into the details here too much because then I go way out of time. But what I saw in the police is that they put the role there, but forgot about them, because they just did their own thing and nobody really knew how to manage this role because it was new. And what happens then is that they can do whatever they want. They can start making their own decisions to a point where it escalates, and in which the objectivity that comes with AI is completely diminished by a brokering role. So an important role, but very important to also manage it. The question is also, who can perform this kind of role? Are these the data scientists that have an interest in also translating their work? Or are these users that have an interest also in the technical side? Basically, both sides could do it, but it is something that needs support, something that needs most of the time additional training in organizations. So a new role with some effort into it. Lastly, and this I also go back to in the final part of the presentation, the broker is not only there to translate AI for the user, but it's very important that the broker also translates the issues of the user back to the developers. So that's the circular reasoning that hopefully is very familiar to you, but often not really in the organizations that put this role there. Most of the time, it's very focused on translating AI into the users, and they forget about the feedback loop. Now, final point, AI will replace jobs, and that's the thing we all have in our minds now, right? Especially with generative AI. So, as I said, I started my AI research in 2016. And back then, there was a lot of fear around AI replacing jobs. That was the traditional machine learning. Then we got rid of that fear a little bit in the years afterwards. Like, oh yeah, well, it's good at something, but not at most of the things that we're doing. And then we had Gen AI, and everybody again got into the fear cycle of now we're really losing our jobs. So let's see what we will say in a few years. Maybe in a few years I won't stand here anymore because AI can do it, or maybe actually we're still here. But these kind of cycles, we've seen them happening over the years and over many years. And that is that has also led on to a different kind of focus when we talk about AI and its influence. One of the most important reports on the influence of AI on jobs was in 2013. Frey and Osborne wrote that report, and there they said that 48% of all jobs would be lost, and I think it was 74% would at least lose half of their job to AI. Everybody was scared. Everybody thought, oh my God, there's no jobs. How are we going to organize the world if nobody has work anymore, etc. But very quickly, actually, they saw that that was not the case, right? We're still all here. We still have a job. So something was wrong about that prediction. And that's the critique around that was that, yeah, well, whole jobs will not vanish, right? We will always have certain things that we as humans can contribute to AI. So let's focus on tasks instead. So what do people do? Which tasks can be done by AI and which tasks can be done should be done by humans? Tasks is a more useful level to look at also when you organize for it, but it's also rather micro. So you focus on only one task and you don't see how it relates to the AI system. You just say humans do this task, AI does that task. And with that, you don't really see the consequences on a more broader scale. So in general, when we talk about changes on AI in work, my focus is more on work processes. Work processes more in the broader sense. How do you relate to AI? So what does AI do for you? And what can I do for the AI system? That also leads to another idea of learning. This is a typical model of learning in organizations in which, in general, we focus very much on the single loop, as they call it. So we have we have an AI system that has consequences for work, and because of that, we adjust the AI system if it doesn't fit. Now, if you look at work processes, you say, no, no, no. If it has certain unintended consequences, you actually also need to readjust the assumptions that you have about work. What do people need to do, and what can they give away to an AI system? For example, in the book we have a case on insurance help desk workers who are now working with a chatbot, and that chatbot could, of course, take over the more simple questions that people had about, for example, scratches on their car. The not so influential questions were now taken over by an AI system, so that these help desk workers had a bit more time to deal with the more intense, more the questions that needed more empathy. Because you can imagine that insurance can also be about death insurance or people who had a car crash and were shaken by that. If you just had a car crash and you need to ask something about your insurance to a chatbot, most of the time that's not really helping. It's not really appreciated. So what happened is these help desk workers were there to empathize with the people. The chatbot was there to take the easy questions where there was no human empathy or emotion necessary. What happened to the help desk workers is that while they before the chatbot, they used these non-emotional questions to kind of relax for a moment. It's an easy question, just get it out. Now I can breathe for a second. All these questions were taken out. So the only thing they had now were the emotionally heavy questions. And these help desk workers were saying, well, by now I feel like I'm a psychologist, but I don't have the training to be a psychologist. That's the kind of double loop learning that is required when you think about work changing in the sense of work processes. Because then you will see, if you look at it like that, then you will see that these help desk workers, they're not just tasked with responding to the more intense questions. They actually need whole new types of training or whole new types of schedules. Because if you have to do these emotional questions for 8-9 hours a day, how long can you do that, right? So that's the more broader kind of loop that you look at when you look at AI changing work processes, in which I'm saying AI work is changing, most definitely. We constantly see that, but it's not being taken over in the sense that we are talking about it. It's more deeply changing, and it requires a deeper change also in the way that we are trained and the kind of requirements that are around work. Now, when we organize for change, questions are, for example, how do you anticipate these kind of changes to work? Because most of the time when we develop an AI system, you cannot see that much into the future that these are the consequences, right? The example of the help desk workers just yet, is that something that you sit back and think about early on in developing the system? I would love to see that. But it's also understandable that this is not the first thing that comes to mind when you develop an AI system to create some time. So more broadly, how do you create space to think about these kind of more indirect changes? How do you make sure that AI is there to support work, not to just create heavier work for people? And how can you use it to then learn from it as an organization, as I just showed in the loop. So this is the part about who are involved. Now the final part, as I said, this was all about what kind of work is changing, right? So how is AI leading to different types of work in the data, in the testing and validating new roles like the brokers, and also more broadly, how does work change? But we often forget this final question. What does all this work change then do to the AI system? Because one of the unique things about AI is that it learns, right? So if we adjust our behavior based on these AI systems, what happens then to the AI system itself? Now, this is to bring all of these points that I mentioned before together. So here you have the AI system with its data and the algorithm embedded. And then the testing and validating is, of course, both influencing the work, but also the AI system itself again. If you test or if you validate a system and it doesn't fit within the organization, it means that an adjustment needs to be made to the AI system itself. Once it's embedded in the work processes, first of all, we need that broker to actually translate the AI system into the work, but we also need that broker to translate the work back to the developer and into the AI system to make sure, again, that it continuously fits within the needs of the organization. So this is a circular system. It keeps on going. When you in your work processes develop or produce data, your AI system will learn from that, if it uses the data, of course. Your AI system will learn from that and will adjust. So this is a continuous cycle, meaning that once an AI system is developed, it cannot just be implemented and let go of. Instead, you actually need to continuously monitor, not in the intensity that you needed to do in the beginning when you develop it, but there is this continuous monitoring and reflection necessary. That's also my advice more broadly to agile organizing, is that make sure to also keep following up on these kind of systems. Normally it's a project and you're done with the project and then there's the next. But with machine learning, since it keeps on learning, at least someone needs to stay in the loop of this one too. Now, I think I stayed almost within the time. Final slide. Because the book is called Managing AI Wisely. This is also my only slide with a lot of text. The book is called Managing AI Wisely for multiple reasons. Indeed, wisdom we thought was more than intelligence, but WISE is also an acronym. WISE stands for Work-Related Insights, Interdisciplinary Knowledge, Social Material Change Processes, very difficult word, and Ethical Awareness. Yeah, Social Material Change Processes was because the S needed. But these are the 4 elements to take with you when you're organizing for and managing with AI. So what does AI need? It needs insights from the work domain to actually fit within the work eventually. So already in the development of the AI system, take those work-related insights, connect with the user so that it's actually fitting their work and not afterwards try to force fit it in there. Very agile thinking. Then it needs interdisciplinary knowledge. All these different people need to come together. Those boundaries need to be blurred. The agile organizing is necessary to actually develop systems that work in a way that is beneficial for everyone, both the organization and the worker. This social material change processes is the loop that I was just talking about. So how does AI influence work, but also how does work then again influence AI? And keep in mind that that AI system keeps on changing. And the ethical awareness is the point that I did not address that much today because there's only limited time. But these AI systems have so many questions in them related to the decisions that you make about them, right? From the data to how you decide that it's accurate enough, to how the broker works, to how you change the work. In all these steps, there are ethical questions to ask and to keep on asking, however much these systems develop and learn. That was my presentation. Thank you for your time. I hope this made sense to all of you. And I look forward to have a bit more broader discussion.
Yeah, great. But first of all, thank you very much. Great. Super. Fantastic. Great. Thanks so much. We have time for some questions. And while you make up your mind, I'll start with mine. I was fascinated by this role, with this role of the broker. I imagine that this broker person is a pie-shaped, M-shaped, comb-shaped kind of type. What would you say about that?
So there are many different shapes of the broker. It really depends on the type of organization that the AI system is implemented in. So it's really it's a role that needs to be fit to the end user actually. So what are the characteristics of the end user? Can it be somebody, for example, within the police? Those police officers are really not tech savvy, so they needed a whole different role. Somebody who did not necessarily come from the police. That was eventually also problematic, but a whole kind of separate role doing that work for them. In the beginning, when I was doing the research, actually police managers, they got a presentation about AI, and one of the police managers said, well, you already lost me at HTTP. That's kind of the tech savviness that is happening there. At the same time, another case in the book is ABN AMRO, a large bank, with their fraud analysts. They are way more tech savvy. They basically were interested in doing this role themselves. So they selected people from within their analyst group, made them the champions, as we often use that term now, made them a bit more savvy about AI, and they became that role. So it can be, they can have different shapes and forms. That's why I find the role very interesting myself too, because whatever organization you come in, there is a kind of role there. They all have a different name and they all have a different kind of, characteristic.
I imagine that the agile coach also is some kind of broker, isn't he or she? But anyway, what other questions do we have from the audience? Shoot. That's interesting. I have so many. Yeah.
Do you imagine that this role can be done by an agent, not a human?
This is actually something I've been talking about quite a bit recently because of the whole emergence of agents. I think it can. It requires a lot of careful prompting and creating an agent that really fits this role. But I do think it can. In the beginning, when we saw generative AI come up, I even wondered if the broker would still be there. So initially, I was doing in the whole hype around generative AI the first months, I was doing a lot of executive education, and I asked all these executives constantly, do you think that this role will still be there with generative AI? Basically, all organizations said yes, but the agent version also came up as, can't we create an AI system to do this? The danger of that, it's even more black boxed, right? So there's I said the objectivity of the broker, manage that, make sure that you keep them in check. In the case of an agent, that's even more difficult. So it's also a more dangerous way of doing it.
Great question, Diana.
One of the things we talk about a lot in Agile is the concept of pairing. More than one person, multiple brains looking at the same problem, giving better answers. And so, to the point you were just making, I'm wondering if there's a pair of a human and an agent
Yeah.
fulfilling that role. And I wondered if you'd looked at that at all.
Yeah, so right now these kind of pairs are not yet there. That would be the thing I would really recommend in general. In general, I recommend the combination between the two, of course. It's never either or. It's really that combination of the two. The thing with these brokers is that especially, so the brokers itself already need quite some training to understand the AI and the domain that they are translating in between. But if you want to pair them up, that really needs some training to make sure that this works well. But yeah, I think that eventually that kind of combination would be the best solution. Yeah.
I have a question more on the human or ethical side. You said you've been embedding yourself in organizations that use that kind of stuff, and basically that organizations use AI to categorize people. Like the police predicts who might commit a crime, or an insurance company might predict who might have what kind of issues in the future. So how, in your experience, does this kind of system change the interaction between one human being and another? So if I'm a police officer and I know this guy might commit a crime, or he might not, how does that change, in your experience, the interactions and the quality of interactions in between people?
Yeah. So that's one of the most fundamental questions for me about AI. Because the thing is, however much you try to make a system ethically correct. So with the Dutch police, so they didn't use the Pret-Pol system because they already knew that this was so contested because it focused on individuals. So they created their own AI system, totally not involving any individual related data or any individual related variables, to make it as neutral as you could say. But then in the end, you did see, and this point that you're pointing, you did see that the moment you start using these kind of systems, it influences the way people work with it. And that's also why we now have the AI Act, which is way more strict on these kind of systems and how you can use it in social settings. Because you just see that whenever people have a system that predicts certain behavior, they will respond to it in the street. To the point where in the Dutch police, they are actually now, that's a longer, way more complex story, which I won't go into now, but they ended up actually preventively arresting people. So crime did not yet happen, but they were just checking people in the area where the predictions were made, saw that people had, for example, burglary tools in the back of their car, and said, yeah, well, you are here. We had a prediction of burglary now, and yeah, you have these tools in your car, so come with me. And they're so proud of that. So that's the thing. It really, you get this mandate of preventing crime, and if you're not careful, it escalates and escalates and escalates into this kind of behavior. And that's not because police officers are inherently bad. It's this push towards prevention kind of creates this type of behavior. And the thing is that we often talk about the AI system and how that shouldn't be biased, etc. But we don't often talk about the aftermath, so the behavior that comes after it, and how do you trigger that kind of understandably human behavior, but problematic human behavior. Yeah.
There is a movie about that, right?
Yeah. Minority Report.
Yeah, and this way lies dystopia, I would say.
Yeah.
It's very interesting. Cool question.
Yeah.
One last question. Yeah.
Okay, thank you very much. It was absolutely fascinating to listen to you. I have one question. I saw recently a study where it says if you have more AI involved, it makes the people think less.
Yeah.
And
Yeah.
yes, and I think, do they rely in the Dutch police, for example, do they rely more on AI than on their own mind?
So in those kind of systems, they were still so simplistic that there was a lot of other things going on that still required them to think. So there, I wouldn't say that they relied more on AI. It's just that these systems, because there's such a belief in it making it more, making work more efficient or more objective, etc., that the push is just so extreme that they have to. So when you have a system that is there to help you prevent crime, you will have to follow it because otherwise you have a social problem, right? So then that push is, I wouldn't necessarily say makes them think less, but they act more towards that AI system just because they have to. But you do see, what you do see now in a few studies we have now with generative AI, is that people just, however much you try to tell them, keep on thinking, keep on analyzing yourself, there is this trust in the outputs of AI because it looks so convincing, right? It's even for me, sometimes I ask to ChatGPT to edit parts of my text, and it immediately, when you see it, you think, oh yeah, I'm convinced, until you start reading it more closely and you think, well, maybe not, because it does things to your text. But that requires the constant kind of critical thinking. And you do see, especially with my students, unfortunately, you see that kind of critical thinking is taken away. So I just hope that this is a temporary thing and that we all realize that critical thinking is still necessary. But yeah, it's a scary development. Yeah. To end on a positive note.
Yeah. Thank you so much, Lauren. It was really great. Thanks. Great.